Hey everyone, I'm Nick McMillan, and today I'm going to teach you guys a little bit about mechanical watches. So the reason I chose this project was recently I had a little side project of my own where I built my own watch. And through that process, I got to know a little bit more about how the movements worked and had to fix some stuff within the movement, and I thought it was really cool and wanted to learn a little bit more about how it works. So to start off, I'm just going to talk a little bit about what types of watches there are today. The most common is the quartz watch. It's battery powered and runs by oscillating a tiny quartz crystal and has a computer track the amount of oscillations and advances it a second at a time when a certain amount of oscillations is hit. The next type, the type I'm going to talk about later in my presentation, is the mechanical watch. This is run off of gears and springs and doesn't require a battery. The last type is the spring drive or the electric watch. It's kind of a combination between the quartz and the mechanical watch because it is battery powered, but it also runs off of gears and springs as well. So the way this works is the battery winds the mainspring, which I'll talk about later, and uses the battery power to actually power the watch. Just like there's different types of watches, there's also different types of mechanical watches. The two most common types of mechanical watches are automatics and manuals, and the distinction comes in how they're wound. Automatics are wound by a rotor in the back, which oscillates due to gravity and the movement of your wrist and winds the mainspring, where manuals have to be hand wound using the crown and stem. Now I'm going to talk about how the movement actually works. So to start off, power is input into the movement. The two ways that these are done we've already talked about, through the automatic winding rotor and through the crown and stem. This diagram shows power being input through the stem. The stem is wound, causing a main barrel to rotate, and inside this barrel is a thing called the mainspring. The mainspring contracts and stores the energy from the crown. Once energy is stored in the mainspring, the energy is released by the mainspring basically uncontracting. This energy turns the barrel and releases the energy through a series of gears into the escapement. The escapement is shown down here and consists of a balance wheel, a pallet fork, and an escapement wheel. The escapement's job is basically to partition the energy into short little bursts, which effectively regulate the time of the watch. This stops the other gears in the gear train and allows for the watch to accurately display time. This animation gives a pretty good view of how the escapement works. The energy comes in through the escapement wheel, which then pushes on the pallet fork. The pallet fork then pushes on a little pin attached to the balance wheel. The balance wheel contracts the spring, and then naturally the spring returns into its original shape, which moves the pallet pin again, moving the pallet fork and releasing the escape wheel. This evenly divides the energy into precisely timed divisions. Most movements beat around 28,000 hertz per second, so that's pretty fast. This animation is pretty slowed down. I keep referencing this automatic winding mechanism, so now I'm going to talk about that. Basically, it's pretty straightforward. This little rotor moves back and forth based on your hand position and gravity. It then turns two gears which are unidirectional, so one gear moves one way and the other moves the other, and they engage depending on which direction the rotor is turning. This then transfers through a gear train into that main barrel that I talked about, and in turn into the mainspring, which provides energy for the rest of the watch. Now that we've talked about the other aspects of the movement, I'm going to talk about the keyless works. The keyless works was a huge innovation in watchmaking. It allowed the users to change the time without the use of a key. This meant that they didn't have to carry around a little extra key to help them change the time. They could just use the stem and crown. Now, the way the keyless works is it's basically a series of levers that changes based on the position of the crown and stem. When you pull out the crown, levers move and different gears engage. These gears can help wind, this gear right here, or change the time, this gear up here, or change the date, this gear down here. And this all just depends on the position of the stem, and that determines which gears are engaged. Now, I know all of that was a lot of information, so just as a little bit of review, I'll walk you through the main parts of my presentation. Most movements beat around 28,000 hertz, so that's 28,000 oscillations of the balance wheel. Power transfers from the mainspring to the escapement to the gear train to the gears holding the hands. The keyless works is a series of levers used to accomplish various tasks such as winding, changing the date, and changing the time. In the future, I would love to research more into this topic, especially what type of new materials are being used in watch movements. For example, some higher-end watch companies are using ceramics and other materials to help improve the accuracy of their watches. Also, I'd like to look into other complications such as tourbillons and minute repeaters. Tourbillons are basically little cages that encompass the balance wheel and rotate it to protect it from gravitational effects, which increases the accuracy of watches, and I think that would be really cool to look into. Here are the image sources for my presentation. One source that I'd like to draw specific attention to is this bottom one, which is a YouTube video which walks you through the power transfer through the gear train of a mechanical watch. It's really cool. If you have like 4 or 5 minutes, check it out. It's pretty interesting. Thank you for watching.